My lab is primarily interested in identifying new diagnostics for the early detection of disease and also identifying targets for disease. My background is I'm a medical oncologist, and in my field in particular, we have learned that the best time to treat cancer is at the early stages. The earlier you can catch the disease, the more success you're going to have at treating it. From our perspective, the most important thing is to identify the best tools we can to find the disease as early as we can find it. Our lab in particular is interested in looking for those early diagnostics. Now, we think this is also true for a lot of other human disease. The earlier you can find it, the earlier you can intervene, and the more likely you are to be successful. Tools that are available to us in the last 10 years have really dramatically changed the way we can look for disease. If you look at the history of medicine, in the 17th, 18th century, pretty much it was just the symptoms that a patient had, and the disease, in fact, was diagnosed by simply saying, the patient has the colic, the patient has the diarrhea. In the 20th century, the predominant tool was the microscope, and the way we diagnosed disease was to look at the microscope and make a pathological diagnosis based on what you could visually see. What's changed now is that we now look at the molecules. We don't look just at the vision, but we actually look at the actual DNA, the genes, or we actually look at the proteins. We now know that, for example, breast cancer, which in my day in medical school was one diagnosis, is now at least 7 or 8 different diseases, each with a different prognosis, each with a different response to therapy. And so these molecular tools have really changed how we look at disease. We're here to understand, what are the proteins that are in our bodies, how do they go wrong, and how can we address that with therapies.